All right, so just as an introduction to why I'm doing mobile app security, and in particular Android security, show you a presentation I gave at DEF CON a few years ago. So what I discovered when I learned how to I went to a conference like a B-Sides, and there was a person there who said, I have a child who's like 3 years old, and she's playing these games on a tablet, and the games are too hard. So I asked myself, how hard would it be to modify that game and make it easier? And he showed how to take apart an Android app and modify it so it's easier. And I said, that looks really easy. It's actually very easy to disassemble an Android app and modify it and see what's inside there. So I said, let me just start looking at real apps from the Google App Store. And I said, I'll start with the banks and insurance companies and stockbrokers because those will probably be very secure. It turned out they are not secure at all. They're amazingly bad. And iOS apps, as far as I can tell, are just as bad. It's a little harder to test them. And this is ridiculous. Management should make it better. So here's the mobile top 10 from OWASP from a while ago. Um, and they have a list of them here. A lot of them have broken cryptography. That's a big one I notice. And almost all of them allow unauthorized tampering of the code, which is what we're going to do. But there's a lot of other flaws. So here's the worst apps I found in the world. This one here is the worst app in the world. And I told this company and they ignored me for 3 or 4 years until I gave this DEF CON presentation. Then they finally fixed it. This is some kind of financial app from India. And they're even certified with an ISO certification, although people tell me this is not a security certification, it's just some kind of business functionality certification. So you download the app, you can log in, and what it does is to decide whether you've logged in correctly, it sends a request to the server, it retrieves from the server your correct password, and then it compares it on the phone, and it logs all of this information. So this is what you'll find in log. I try to log in. Here's the password in the database. Here's the password from the user, and they didn't match. So it downloads every password in plain text, unencrypted over HTTP from the server for anybody who logs in, and then it puts it in the log on the phone so anybody can steal it. There's only a few apps I've ever seen that are this terrible. This is obviously the wrong way to do it. What you're supposed to do is make an encrypted connection with HTTPS and send the password that's typed in to the server. It then gets compared on the server to the right answer, and the server just replies yes or no. You don't download the right password onto the phone and compare it on the phone. But that's what this app did. So I gave students homework like steal the password from my account. Because all you have to do, the hash of the password would be better also. Yes, Sable. But really, there's no reason for the correct password to move down to your phone at all. You should just take the user's inputted password and send it to the server and then compare it there. So this is spectacularly bad. You can get into anybody's account by just trying to log into their account and looking at the log on the phone. It'll tell you what the right password is. And the other one I found, which was amazing, was the University of Houston. The University of Houston had an app for the alumni. And as you know, all college teachers, alumni are very, very important at colleges. They donate a lot. So they made a special app for them. And so you'd load this special app, and then you could start typing your name to look for yourself. And so when you did this, I ran the data through Burp to see the request. And I noticed here's the post requesting some data, and the response is 351 kilobytes of data, just from like typing in the first few letters of a name. I said, why was that so big? The answer is every time you use the search feature, it downloads the entire database of all the alumni with their email, their credit card number, their password, their address, their phone number onto the phone, and it's just sitting there. And it does it with broken HTTPS, so you can man in the middle it and read it. So again, just amazing. And now I told them, and they fixed it. So that was good. The people in India didn't care less, but the University of Houston participated in cyber competitions. I've learned after reporting many, many vulnerabilities that most companies have no idea what to do and they won't fix it, and they might even blame you if you report a vulnerability. But at a college with a competition team, what you do is you contact the people in the cyber competition team, and then you'll reach the right people. So I found the coach of their CCDC team and told that person about this vulnerability, and they fixed it and quickly. So that's what you do. So Android apps tend to be very bad, although usually not that bad. So I tried the top 10 banks, insurance companies, and stockbrokers, and I found that essentially all of them are vulnerable to code modification. That's the most common vulnerability, but a lot of them have other problems too. Um, Code modification is the main one. And one thing that Android developers do not seem to know is that when you distribute an Android app, it's essentially delivered with the source code because Android apps are written in Java and they're not compiled down to native code. They're compiled down to bytecode, which is small e code, which is very easy to read. So, for example, if you take the TD Ameritrade investment app and then you log in, um, it puts the password in the log. This is a common flaw. It the log is just in a log, especially on earlier versions of Android, is just a public syslog available to every app on the device. Um, Now it's more restricted, so this is less of a problem, but still, it is a very bad policy to put sensitive data in the log. So that's one thing. Um, this app called Mayo Clinic Medical Transport was interesting. This is apparently something like a textbook of medical symptoms that people are supposed to use in an ambulance, but it's protected by a password. And I wondered what the password is. So all you can pull the app from the phone with ADB. We'll do this in the projects today. Android Debug Bridge lets you download an app from a phone. You can then unpack it with APK tool. It's basically a zip file containing all the components. And then you can just read the source code. And you can just look for things like secret password. And when you do, you'll find the secret password to get in to open that. So it's password protected, but the password is just hard coded in the app and labeled secret password, so it's easy to find. And this is the thing that Android developers do not understand, obviously. If you're a C++ developer and you compile something like Microsoft Office and then distribute it, it appears without any symbols. All the names of the functions and the names of the variables are gone, so it's difficult to reverse engineer. But in Android, the names of variables and names of method are preserved. So you can look for a meaningful name like secret password and find secrets. And all these things I wanted to obey, responsible disclosure policies. So I would notify these app developers, and when they ignored me, for after 30 days, then I used them for homework. So this guy got mad at me and told me to quit bothering him. So anyway, he had a whole chain of apps all with the same flaw. And so another flaw is people that break HTTPS. This is also quite common, where you make an HTTPS connection, so it's encrypted, but they do not verify the identity of the trusted third party. They just don't complete all the steps in making a complete HTTPS connection. So you can put a interceptor in the middle, like the burp proxy, that gives it a fake certificate, and it will accept that because it doesn't bother contacting a trusted third party. It's a fairly common flaw, and this has actually been determined to be unacceptable by the Federal Trade Commission. They sued these companies that did this and punished them for breaking HTTPS. So you'd think people would care, but they mostly don't. Then there's another thing that happens. This is a very strange thing. So if you have a user log in, and once you log into a site, then you uh, close that app. When you reopen it, you don't want to have to log in again on the phone because typing in a password on the phone is difficult. So you want it to remain persistently logged in. Now, how does the app remember who you are? Um, well, here's the right way to do it, is the way you do it on websites. Australia does it correctly. When you log in Target Australia, um, you send it your name and password here. Here's my name and password being sent up over HTTPS. So this is the correct thing to do. And then the server replies and it sets a token, a cookie, a long random number, which is my token, and that's what it remembers. And then when I come back and reopen the app, it sends the token up to the server, which figures out who I am. That's the right way to do it. This is how web pages work. Unfortunately, an amazing number of Android apps do not work this way. They do this bizarre thing. Here's what Staples does. You log into Staples, and then it stores your password on the phone. It calls it encrypted password. It's just base 64, but maybe a little more than that. But anyway, it stores your password on the phone. This is a very bad idea. It makes an extra copy of your password and stores it locally on your phone, and there's no reason to do this. You should just use a cookie. And I found a nice website saying how to store passwords on a phone. Here's what you do. Best way, don't. There is no reason to do this. If you think you need to do this, you just haven't thought through your application's flow. You never need to store a local copy of the password on the phone. However, if you decide you have to, there is a secure place to store it. There's an Android keychain and there's an Apple keychain or key vault or something. There is an API and an encrypted storage location on the phone for exactly this reason, for you to put your secrets in. I've never seen any app correctly use this though. Then another way you could do is you could encrypt with a public key where the private key is on a server. That would be pretty secure. The thing stored on the phone would not be reversible. It can only be reversed by after it's sent up to the server. But what almost every app I tested does is encrypt it with a private key and then try to hide the private key on the phone. This is a terrible idea, especially since I can see your source code. You really can't hide anything from me. And of course, another popular solution is to just store it in plain text on the phone. But the most popular item is number 4. And I must say, after auditing hundreds of Android apps, it seems to me like there are about 4 companies that make Android apps, and they all use the same procedures and libraries. And I've gotten used to recognizing the 4 types of Android apps there are. And a whole bunch of them, this is their standard. Encrypt with a private key and then hide the private key on the phone, which is essentially the same as just storing it in plain text on the phone. So here, for example, another thing you can check is type of encryption. Here's what Staples does. If you make a password, which is 32 identical characters and then some other characters, you can get the encrypted password. And if you reverse it from base 64, you'll see that the first 16 characters repeat. So this means they're using the encryption mode, ECB mode, encryption codebook, where each block of input is independently encrypted with the key. So if you have 2 duplicate blocks of input, the first 16 A's and the next 16 A's, you get exactly the same output. So this is another encryption failure. And so you can read the Smalley code. This is what the source code of an Android app looks like after decompiling, which is not very much. You can just read username, encrypted password, so you can see how it builds the encrypted password. So what it does is it takes the brand of the phone, the device number, the model number, the serial number, and the package name, which is the name of the app. It concatenates them and runs them through SHA-1, and it takes the first 128 bits of the SHA-1 hash, and that's the key. It adds extra salt and then these other predictable things. That's what the secret password is to decrypt the data. So it's ridiculous. And so you can just decrypt it with online tools or with Python. You can write it. I made a script that will just steal the password, recover it from the locally stored data on the phone. And, I notified them, but they didn't fix it and they became homework. So this one got a lot of attention. I showed how to steal data from the Staples Android app, and I gave students homework stealing my credit card out of the Staples account, part of it. And I made videos, and Staples contacted me and said, you need to stop doing that. But I asked my lawyer, and he said, no, that's fair use. And then when I tried to demonstrate it in Washington, D.C. at a conference, they fixed it right before my presentation. But what they did was they just blocked running the app on a rooted device. And I didn't go back and check, but I doubt they fixed it any other way. This is another thing you get used to in the world of vulnerability disclosure. You typically get patches like this. We have patched the vulnerability you reported. They block one little detail of the exact attack, but they don't actually fix the problem. And I don't know if Staples did that, but that's probably what they did. So you get used to that. Here's apps that have plain text password storage, like Ace Hardware and McDonald's. Here's plain text login, sending data unencrypted over the internet. And here it is sending by HTTP, logging into 7-Eleven, just sending your password up there. This thing was Price Tracker for Amazon. It's not an official Amazon app. It's a third-party app that will check the price of an Amazon product to see when it falls to a low enough price and then buy it for you. And it does that by logging into your Amazon account. And it does that by storing your password locally and using it to log in, and it sent it with broken SSL. And I contacted the developer, and he actually answered me. I said, dude, your app is not verifying the certificates you used for HTTPS connections. And he replied, he said, yeah, I just added that. It's great, isn't it? And I said, wait, that makes the app insecure. He said, yeah, but the problem is, Before, in some Android versions, if the SSL certificate fails, the page just turns blank. And that was irritating my users. So if you just turn off that security stuff, it works better. The app is better now. And I went back and forth with him several times trying to convince him that this is actually a bad thing and he should fix it. I don't know if he ever really fixed it. But anyway, that was his claim. It's a feature. This was the bug causing people to see blank screens, was the SSL verification. He fixed it by turning off SSL verification. And here's a bunch of apps that store your password with reversible encryption with an encryption key that's easily found. And Home Depot, for example, does it. And you can just write a simple Python script to recover the password by decrypting it. All right. And Walgreens also. And many companies have multiple flaws, investment apps too. And so then I tried iOS apps. Now it's harder to reverse engineer iOS apps. You can do it somewhat. Joe McRae is a cybersecurity teacher like us, and his presentation on reverse engineering was really helpful to get me started doing this. And Georgia Weidman, one of his students, wrote a textbook that has a very good description of how to do this and made it possible for me to make an exploit development class out of it. And one of the students that took that class made the latest iOS jailbreak, the Checkmate jailbreak. Not that I taught him how to do that, but after he was a Google engineer, and then he took my class in exploit development, learned how to do it, and then he spent like a month or 2 months staring at IDA Pro, analyzing the boot track. I don't know if no, there's another guy that gave up iOS exploits. It wasn't this student. There was a new guy that just said it's useless. I heard him on the latest Pulse Security Weekly. But he was a part of the jailbreak community. He was one of the developers of this exploit, and the guy that just quit is another part of the same group. There's a sort of club of independent iOS security researchers. So anyway, then I tried Blue Cross apps for health insurance. I discovered something. Blue Cross doesn't have like one central app. They have all these branches, and every branch writes their own app, and a bunch of them do bad things. So here's one that stored their password insecurely. Here's Blue Shield that failed to validate the certificates. And then I tried colleges like West Point. Turned out the West Point app transmitted passwords insecurely. And in fact, it also, because it had internal to the app a way to put things on Twitter and such, it exposed not only your, I think it's the one, exposed not only your college West Point login, but also your Google login and your Twitter login. So I notified them, and then I tried other apps, and it turns out that there's a whole chain of apps, like dozens of colleges all use apps from the same company, and the entire product line had this flaw. So I contacted them directly, Straxis Technology, and they fixed their entire product line. So that was a success in vulnerability disclosure. Most people just don't care at all when you tell them about vulnerabilities, but these people responded quite well. And Zillow caches passwords insecurity. It lets them go in the cache. The stock app sends things with plain text. And I was surprised to find this on iOS. All those were on iOS, by the way, because I read an article years ago that said iOS was now no longer going to allow unencrypted communication. But it turned out that they have this feature in the operating system, and they've had it for many years, preventing insecure network connections, but it's not enforced. You can turn it off for your app. It operates by default for certain ones, and you can turn it off. So, and it turns out a lot of people do have apps that send plain text data, including login data, on iOS. So I found my college, City College app, did this. And again, the whole product line from Dub Labs did it. All these apps transmitted passwords with broken encryption. They weren't unencrypted, but they were sent with HTTPS that did not verify the certificate. And also these financial apps, Jack Henry and Associates, a whole chain of apps there had the same logged the passwords. And here's another a bunch of financial apps that log the passwords and so on. So, it's just amazing how bad it is. And this, I think, is why you need ethical hackers and security researchers, because what people apparently do is they pay for someone to write an app, and they just test the app to see if it works, and they don't even examine its security. So, that's why I made this course in hacking mobile devices and a course in cryptography to try to train people to do better. And my fundamental point is you should have managers, and your manager does not have to be super technical. Your manager has to ask you very simple questions. Do you need this data? Is it encrypted? Where did you put it? And where is the secret key? you should be able to get clear, simple answers to these questions, or you're not doing your job in management, in my opinion. You should be overseeing what your staff does and demanding that they give you clear answers for this stuff. And if people just did that, all these flaws would not be happening. So that's what I wanted to show you. Let me stop this one.